Hey, this is Adrian from the company Sasuko. I quickly want to show you what I played with last week with the public SPARQL endpoint from the Swiss government. So this endpoint is relatively new. We started that 1st of January of this year officially. It's called Lindas, and we have a SPARQL endpoint here. And as you can see, I can get some stuff back here. But that's not what I'm gonna do now. I actually started playing with something which is called LD-VOWL. I hope I pronounced that correctly. It's basically a relatively old project available on GitHub, very little license. You can play around with that on your own, just search for vowel. There is WebVowel. We will gonna have a look at LD-VOWL this time. And when you click here, you can see what we will see later. It's basically a visual specification which says, or which shows you what you have in your ontology or in your endpoint. So if you want to know what you see, have a look at this document first. I just give you a brief overview. When you go to the endpoint, you can basically specify a graph URL. I have the graph URL of the cluster, of the production cluster. This is already the pre-calculated thing. Let me quickly show you what happens. I configured it to get the top 5 classes in this endpoint, so it will not run very long this time. But you see that it's continuously doing requests to the endpoint and stuff pops up here. So apparently in this endpoint we seem to have a lot of observations, but with the top 5 you don't see too much linking. You have some other stuff. Let's see what this is. This is a concept from SCOS. Here we have some geometry, here we have some civic structure, and so on. So in this particular example, where do we see what we did? We had 66 requests so far. It's almost done. It won't do much more. I have a pre-populated version of that, where in the settings I basically said get the top 30 classes. When we go back here, you see a lot more bubbles. You can zoom in and out as well. And the really interesting thing here is that this is a public SPARQL endpoint from the government, and it doesn't have a super strong linking right now. So the data sets are linked sometimes, but not all the times. But what you can see actually here is not directly the linking of the data set, but the linking of concepts. So basically you see a picture of shared concepts within these endpoint or within this endpoint and how they are linked within each other. And that's like super interesting to see. So obviously I know this data set, so when I zoom in, I can explain a bit what we see, and let me give you an idea of what we see here. So this one here, I know that this is municipalities. This is actually the mother of all data sets we published in Switzerland. It's the historicized municipality index, we call it. This is basically all the Swiss municipalities over time since, I think, early 60s or 70s, I forgot. So basically here you can really see what is happening with municipalities. We have a lot of small municipalities that merge. You can basically find that in RDF. And you see we have a concept which is called municipality version. This is a class. This seems to link to something which is a political municipality, and it also seems to link to something which is called a municipality change event. It also points to something that is simply a municipality. So you see we have a distinction between a municipality and a versioned municipality. That's simply because we want to track these changes in here. That's the model we use. So this one we created many years back, and for a really long time that was basically the only thing we had. And when we start to transform other data, when it's government data, it's often related to municipalities. So it's really cool to see now that I can see in this data, in the instances of this data, you see always here an instance count, that we really seem to have other data which points to these concepts. So let's zoom a bit out. I see another bubble here. This is probably the SCOS concepts, right? And you see that they seem to point to the versioned municipality in here via something which is called admission mode. So I could dig deeper into this schema. I have something else here. So this is district. This is another geographical grouping in Switzerland. Like municipalities are linked to a district and then to a higher concept which is called canton. So if I would dig deeper enough, I would probably find that as well. You also see like what we have strings in there, we have integers attached to these things, so you get a better idea of how this stuff looks like. So let's look at some other stuff. I don't want to go through everything, but something which is really cool is this one here. These are so-called relations. This is from the public transport provider in Switzerland, basically all the relations between two public transport stops. So it's like the edge between two stops. And this is a very new data set. We didn't really announce that much yet, but you can see that these relations seem to link to something which is called civic structure. This is the public transport stop itself. And the public transport stop is obviously in a municipality, like every transport stop can be assigned to a municipality. And then you see that we indeed have a property called municipality, and that points to the municipality we saw before. So even if you don't think that you directly link to it via other relations, you might actually start to link stuff without even really realizing it. And that's really nice to see in here. And then when you look at this relation, you immediately start to see the model here. You see that the relation seems to point to something which is called a zone. Now this gets very particular for this data set. I will not explain that in detail. You see that the relation also seems to have a pay level, seems to be related to what you pay for that stuff. The zone itself points to a provider, so the public transport provider. The public transport provider itself is a schema.org organization. We see that the pay level we had here seems to point to a tariff. The tariff again is linked with the provider and so on. So you can really explore what you have in an endpoint, even if you never really interacted with that endpoint yet. Another cool thing is that you can see that there are some seemingly unconnected data sets. So we would have to dig a bit deeper. Maybe I would also have to change the settings here that I get more than just the top 30 classes. Then maybe it would start to link. But I can see quite well in here that we seem to have one data set which doesn't really seem to use a lot of vocabularies we had in other data sets. So when we go into here, we seem to have around 10,000 instances of something which is called schema.org organizational role. It seems to point to something which is a person, and it seems to get pointed to from something which is called government organizations. And it seems to have a postal address. And I'm pretty sure I know which data set this is. This is not something I did, but it's also cool to see that sometimes you have data sets which are, at least at the moment, not linked, or they don't share concepts with the other data in here. So that's it. There are clear limitations of what you can do with LD-VOWL, but I was really impressed to see how well it shows how you start to build a graph, even when you have seemingly disconnected data sets and you simply put them in the same endpoint. At one point you really start to get a very powerful graph, and you can zoom into that stuff. I don't think that LD-VOWL is the best thing to play with. I couldn't find a way to persist it so far, so I cannot share this link, for example, with exactly that work. I can only give you the endpoint, and then it has to do the queries. And in this one you see, no, that's actually not true. I think for this picture it did around 1,500 requests or something, so it's quite heavy on your endpoint. But nevertheless, start playing with it. It's a really cool thing to get an idea of shared concepts linking between data and instances of data.